Hi and welcome. In this video, we will start with the calculation of measures of variation. For that, consider a quantitative variable x, and suppose we have collected data on this quantitative variable from an underlying population, and that data is being listed as x1, x2, x3 up to xn. Remember that n is the size of the population. Then the first measure of variation is the range, which is actually an interval containing all observations collected on the variable x. In other words, the range of this variable x is this interval starting from the minimum and ending at the maximum value on the variable x. The length of this interval, as we know, is the maximum, the largest, minus the minimum, the smallest. For instance, consider the age of all 9 employees of a technology company in Kabul given here. In order to find the range and the length of the range, what we need is the minimum value and the maximum value here. After checking through, we see that the minimum is 22 years and the maximum is 37 years. Therefore, the range of the variable age is 22 to 37. Of course, the length of the range is 37 minus 22, which is 15 years. That means the difference between the youngest employee and the oldest employee in this company is 15 years. The second measure of variation is interquantile range. Interquantile range is actually again an interval containing the middle 50% of all observation being collected on the variable x. What do we mean by the middle 50%? That is, the interval is starting from quantile 1 and ends at quantile 3. Of course, we can calculate the length of interquantile range, which is Q3 minus Q1. Hence, in order to find the interquantile range and its length, we need Q1 and Q3. We already calculated Q1 and Q3. Q1 is 25 years, Q3 is 33 years. Therefore, interquantile range is 25-33, this closed interval, and the length of interquantile range is 33, which is Q3, minus 25, which is Q1, which is 8. That is, the difference between Q1 and Q3, which is the first and the third quantiles, is 8 years. The third measure of variation is mean absolute deviation. Mean absolute deviation is actually a method which is measuring the average distance of each observation from the center. Mean or median can be used as the measure of the center. In other words, we try to find the average distance of every observation from the mean or from the median. The formula for mean absolute deviation is 1 over n, the sum of absolute value of xi minus mu. Mu is being the mean of the variable x. Remember that if you collect data from a sample, some literature or some books use n minus 1 instead of n. But if your sample size is large, n and n minus 1 doesn't make that much difference. That means you're allowed to use the same formula for the sample as well. Going back to the example of age, first of all, we find the mean, which is 1 over 9, the sum of all observations, which is 29 years. Then we use this mean in this formula to calculate the mean absolute deviation. In this table here, the observations are being listed here. Then mean is being separated from each observation, that is 22 minus 29, 37 minus 29, 30 minus 29, 23 minus 29, and so on and so forth. Finding the difference, and then in this column we find the absolute value of the difference because we need the sum of the absolute values. Finding the absolute values, we get all positive numbers here. Then we find the sum of all these numbers here, which is the sum of all absolute values. Therefore, the sum of xi minus 29, absolute value, is 38. Now we divide 38 by n capital, which is the size of the population. Hence, mean absolute deviation is 38 divided by 9, which is 4.8 years. Therefore, on average, the distance of each observation here from the center, which is 29 years, is 4.8 years. Thanks for watching and good learning.